So a single particle like an electron can become entangled with itself because if I make a measurement of that particle, say I send the electron through both slits and at the same time I send a photon at just one of the slits to see if it's there, even if the photon doesn't detect it, the interference pattern disappears. It doesn't land following this interference anymore. It follows this pattern, and it will correspond to the portion from the slit that we didn't measure it from. So sending a photon to measure the particle changes the particle's distribution in space, whether we measure it or not. If we do measure it, it behaves as if it came from that slit and lands around this region. The point I'm emphasizing here is that when we get information about which slit the photon or electron came from, that gives us the loss of the interference pattern if we don't know which direction it came from. And since we still get information about where it came from, even if we don't measure it, we can think of that as being an entangled state where we make a measurement at one point and we affect its distribution even if we're not directly physically in contact with it.